let's talk about arithmetic sequences. Arithmetic sequences are just lists of numbers, a progression of numbers. This particular sequence, Tn, starts with 5 and is built by adding 1. A, the anchor, is the value of the first term in the sequence, and D, the common difference, is the common adder that you use to go from term to term. So if I adjust this and make it 2, then I start with 5 and I add 2. A sequence that's defined in this fashion, or a rule that's defined in this fashion, where there's an anchor term, a first term, and then a building rule is called a recursive definition. So the recursive rule for arithmetic sequences is add the same thing over and over again. When working with sequences, it's important not to confuse n, the position number, with tm, the term's value. It's pretty easy to confuse them, unfortunately, because often sequences start in position 1 and have their first term also have a value of 1. That need not be the case. The first term could be worth anything, but very often people mix these two things up. All right, that said, let's take a look at what happens when we graph an arithmetic sequence. If we plot the position number versus the term's value, what we'll see is the points that result will fall on a line. And if I increase the initial value, that line will move up. If I decrease the initial value, that line will move down, but it will stay a line. If I adjust the common difference, it still remains a line, but the slope changes. So if the slope is -2, the common difference is -2. If the slope is 2, the common difference is 2. Right, so the common difference seems to be creating the slope, but not the y-intercept, because you see this first point right here? This first point right here is not on the axis. All right. Well, very often when we are recording data, we're not counting the recording position. What we're counting, or what we're measuring, is the elapsed time. The elapsed time then is just the count minus 1. So let's say we're counting every second. When n is 1, the elapsed time is 0. When n is 2, the elapsed time is 1. Let's take a look at what a graph of that will look like. Alright, so here's the graph where we have elapsed time on the x-axis and the term's value on the y-axis. And you'll notice at that point, which was not a y-intercept, all of a sudden is a y-intercept. And so now the connection between arithmetic sequences and linear functions appears very obvious. Let's just add a least squares line, and we can see the slope is 2, the y-intercept is 4, the common difference is 2, the anchor term is 4. It's a perfect fit. So clearly, arithmetic sequences and linear functions are closely related.